rate of diffusion and the factors on which rate of diffusion depends. So they are the temperature and molecular mass of the particle. So first of all, I'm going to discuss with you the temperature on which the rate of diffusion depends. We know that in case of the diffusion that the particles move and they collide, and when they collide, they mix. And such a spontaneous mixing is called diffusion. When the temperature is high, the particles gain energy, their kinetic energy will be more and more, and with that kinetic energy there will be more collisions. With more collision, more mixing, and the faster the mixing will take place, the faster the diffusion. So under high temperature, the rate of diffusion will increase. For example, water and the coffee. If the coffee is mixed with the water, the temperature of the water is at a room temperature, the diffusion will take place. But if we take boiled water, the rate of diffusion will be faster, and the coffee will mix in the boiled water faster than the room temperature water. We know that in case of diffusion, the particles move, and when they move, they collide, and due to collisions, they mix, and this spontaneous mixing is diffusion. And when the temperature is high, particles have more kinetic energy, they can move faster. When they can move faster, they can make more collisions. With more collisions, mixing is faster, and the rate of diffusion will be faster. For the second case, the molecular mass of the particle, the lighter particles can move faster. When the lighter particles move faster, they can mix faster, they can make more collisions and can mix up quickly and show the higher rate of diffusion as compared to the heavier molecules. So as an example, it is the 1 meter long tube. On one side there is concentrated ammonia solution, and on the other side is the concentrated hydrochloric acid. The concentrated ammonia is lighter as compared to the hydrochloric acid, which is heavier. The ammonia molecules move and the hydrochloric acid molecules move. Because ammonia is lighter, it moves faster as compared to the hydrochloric acid, which is heavier. So ammonia molecules cover 60 centimeter distance, and hydrochloric acid molecules cover 40 centimeter distance, and white solid ring is formed of ammonium chloride. That tells us that ammonia molecule, because of lighter, can move faster and show a higher rate of diffusion as compared to the hydrochloric acid. So this was about the particulate nature of matter. As a summary, I can recap the points we discussed in this chapter. The basic idea we discussed in this chapter, that matter is made of tiny particles, and these tiny particles move. The rate of movement is different in case of solids, liquids, and gases, but these, whether it is solid, liquid, or gas, they are made of particles, and they have some empty spaces between them. So matter is not continuous. Matter is grainy, and matter always takes the form of particulate. So this is my primary objective in this chapter. We collected the data, and I discussed with you that matter is grainy, matter is not continuous, matter is in the form of tiny particles with some empty spaces, and therefore different processes and different phenomena occurred before us, and this is all we discussed in this chapter. particulate nature of matter is the basic and first theme of my chemistry, and it is the core concept and the central point of my chemistry discussion, and this is the first cardinal principle of chemistry, that all matter, all stuff, everything around us is made of atoms, is made of tiny particles which we call atoms, and they are not at rest. They have some empty spaces between them. These matter is not continuous. Matter is grainy. Matter is in the form of tiny particles with some empty spaces and is not continuous.